Yeah, now we'll discuss what is common in all acids, right? So why do we get this question? Why do we get this doubt? Is something common in all acids? Why do we suspect this? Because in all earlier topics we discussed, all acids, right, reacts with metals to produce salt and hydrogen. They react with metal carbonates, produce carbon dioxide gas. They react with metal hydrogen carbonates, produce produce carbon dioxide gas. Acids react with metal oxides or metal hydroxides, produce salt and water. So in all those earlier cases, we found something common, like all acids are behaving same with the different materials. So it is why all those acids behaving same? Because something might be common in all the acids. What is that common thing? We are going to identify by means of a small activity here, right? Now what is on the board? To conduct this activity, to identify the common thing in all acids, we need small experimental setup. And this experimental setup, you can see we need a sample of solutions. We need sample of solutions. I will tell you what sample of solutions are to be taken. Then you can see a beaker which is filled with some sample solution, and in which two graphite rods are immersed. What are these? Graphite rods. Why I took graphite rods? Because graphite is actually made up of a non-metal carbon, which is a bad conductor of electricity, carbon. But in the form of graphite, carbon is very good conductor of electricity. So carbon rods are oftenly used as electrodes because of their good conductivity of electricity, right? So graphite rods are immersed. To these two graphite rods, what is connected? These two graphite rods are connected to a battery, right? And one is connected to positive terminal and one is connected to negative terminal, right? And a switch is connected. What is this reference? A switch, and it is an LED is connected in the circuit. Similar setup is seen in another case also, like similar setup. Graphite rods, battery, switch, and an LED and a sample of solution. I will tell you what solution we have to take, right? Now, to perform this activity, let us take some samples. What are the various samples? Let me take dilute hydrochloric acid, dilute sulfuric acid, dilute acetic acid, dilute carbonic acid. Let me also take some ethyl alcohol, and lastly let me take some glucose water, right? We get glucose powder, and that glucose powder is dissolved. It is soluble, dissolves in water. Like glucose is nothing but a sugar. It dissolves in water and forms glucose water. So these are the different samples that I take, right? And now each of this sample is added in this experiment, is added to the beaker, right, to make a solution, right? And that solution is used to identify the behavior of acids and what is acids. Here you can see the samples that I have taken: HCl, H2SO4, acetic acid, this is carbonic acid. All the first four are acids. And ethyl alcohol and glucose, if I write the formula of ethyl alcohol, we write it as C2H5OH, right? And glucose, if I write C6H12O6. Now carefully observe the formulae of the samples taken, and you just guess what is common in all acids, or all the samples taken here. What is the common element? There is one common element. What is it, Nana? It is hydrogen. You can see hydrogen in HCl, hydrogen in H2SO4, hydrogen in acetic acid, hydrogen in carbonic acid, hydrogen in ethyl alcohol, and also in glucose. These all samples that are taken are hydrogen containing compounds. Now each hydrogen containing compound is dissolved in distilled water. All these things are generally one by one dissolved in distilled water, right, in order to make a solution, right? Now let us see first first sample solution, let me take a dilute HCl, add it to distilled water, we get a solution, dilute HCl solution. Then after adding dilute HCl solution, let us, you see this switch, is this switch open or closed? It is open. Now if I put a dot in between these two brackets, it represents a closed switch. Now the circuit is closed, and what happens? We have LED. LED is used as indicator here. Indicator means not acid base indicator. This LED indicates whether current is flowing through the circuit or not. Right? Now when acid solution is taken, switch is closed. What do you think? When LED glow or not? For each case, right? Let me take the sample in each case, right? And LED glows or not? LED if glows, let's keep a right mark. If it doesn't, let's keep a cross mark. Okay, first what is the sample? Dilute hydrochloric acid sample is taken in the test tube, beaker here. Now when switch is closed, we can see, can we see? LED glows or not? The LED glows brightly. LED goes bright. Okay, now in the first four cases, like all these cases, let's make equal concentration of solutions, right? Now we can identify. When you take dilute HCl, LED glows. When I take a dilute H2SO4 solution, LED goes bright. Then if I take a acetic acid, CH3COOH, in this case also LED glows, but it's not brighter as in the case of HCl and H2SO4. It brights dim, it glows dim. Then if I take a carbonic acid H2CO3, in this case bulb glows, but the LED glows dimmer, right? And lastly, if I take a ethyl alcohol C2H5OH, the bulb, it doesn't glow. If I take even glucose solution C6H12O6, the bulb does not glow, right? Now these are the observations using these experiments, right? So these setups are used. These are, in this case, what I say, I write this LED is glowing, right? And in this case, when switch is closed, the LED is not glowing. It does not glow, right? It glows. In which case it is not glowing if I take here C6H12O6 glucose, or if I take C2H5OH ethyl alcohol, it is not glowing, whereas rest of all acid solutions, it is glowing. So now first thing, why this sample of solutions are able to glow LED here? Because this sample is taken is a good conductor of electricity. The solution taken acting like good conductor. This solution taken in the second case where LED is not glowing, acting like a bad conductor of electricity. Bad conductors. Now, whether the sample is conducting electricity or not is identify the glowing of LED here. Whenever LED glows, the sample is acting like a good conductor. But how the solution became a good conductor? We know current, like whenever a circuit is closed completely, if a current can like travel throughout it, the flow of charges, you've seen what is current, Nana? Flow of charges. Whenever the flow of charges is allowed through the solution, then it acts like a good conductor of electricity. And now we understand, when you take these first four solutions, the current is flowing through them because they are allowing charge to flow, whereas these two cases, they are not allowing charge to flow through them. As a result, they are being bad conductors of electricity, right? Now, what is responsible for conducting or traveling, like flowing charges in this sample solution? Now, whenever the sample solutions are added, like HCl, if I take HCl is added, this HCl when added to distilled water, aqua solution I'm writing, it's splitting into H plus ions and Cl minus ions. So ions are produced, right? If I take HCl, it is splitting into H plus and Cl minus. If I take H2SO4, it's split into H plus and SO4 minus 2. It's split into CH3COO minus and H plus, right? It's split into H plus and CO3 minus 2 ions. So ions, they are ionizing and producing ions in their aqua solutions, right? These charges made the solution a good conductor of electricity, whereas in the case of glucose and ethyl alcohol, okay, they are not able to produce ions. No ions are produced. So no charges are present. No free ions are present in the solution to carry the charge. Okay, as a result, they are being bad conductors. But here, this sample of acids in water undergoes ionization, producing ions. These free ions make the solution a good conductor of electricity. Is it clear? Now, whenever, like in this case, right, all this, what is common, I told you, all are these hydrogen containing compounds. Though they all these contain hydrogen, they are not producing hydrogen ion. But if you see all these acids, right, negative ion is different: chloride ion, sulfate ion, acetate ion, carbonate ion. But positive ion, you see H plus, where is this is H plus ion, H plus ion. H plus ion is common in all the acids, like hydrogen is present, and these solutions are able to produce hydrogen ions. These hydrogen ions and along with other negative ions responsible for the conductivity of current in this solution. Okay, now in case of glucose and ethyl alcohol, though they contain hydrogen, they are not ionizing to produce hydrogen ions. As a result, sample became a bad conductor of electricity. Is it clear? Now, from this, we can identify what is common in all acids. All acids contain hydrogen and they produce hydrogen ions. They undergo ionization and produce hydrogen ions in their aqua solutions. Now, from this, we can define the substance that contain hydrogen and that produce hydrogen ions in their aqua solutions are called acids. So, all acids contain H plus ions common in their aqua solutions, right? Whereas glucose and ethyl alcohol like substances, though they contain hydrogen, they are not producing H plus ions, and as a result they are not acquiring any acidic properties. They are not behaving like acids. Okay, this you can identify using a indicator test. Whenever you add an indicator, by observing color changes, you can identify are they acids or not. From this, an important conclusion, right? We can conclude two things now, right? One is acids. All acids contain hydrogen, they produce hydrogen ions. And the second thing is, all hydrogen containing compounds are not acids. All acids contain hydrogen, but all hydrogen containing compounds are not acids. Like glucose, ethyl alcohol, though they contain hydrogen, they are not acids. Now let us see one more observation. Let us understand. HCl is an acid, H2SO4 acid, CH3COOH acid, and H2CO3 is also acid. But in all the four cases, when they are taken equal concentrations, the brightness of LED is not equal. In case of HCl and H2SO4, LED glows very bright. In case of acetic acid and H2CO3, the LED glow dim. What is the reason? Though their concentrations are equal, they are not able to produce equal number of ions, right? In this case of HCl and H2SO4, they ionize completely, whatever. For example, for your easy understanding, I will tell you, if I take 100 molecules of each of these four acids, hydrochloric acid, sulfuric acid, acetic acid, and carbonic acid, each 100 molecules I have taken. Imagine, taking 100 molecules is not possible exactly, but you just assume and you understand. 100 molecules of each acid, I take 100 molecules of HCl, add to this container, distilled water present in the beaker. Then HCl, since it is a strong acid, it undergoes complete ionization, and we imagine out of 100, 99 molecules undergoes ionization, and all the molecules, 99 out of 100 means most of the molecules, they produce ions. And because one molecule split to produce two ions, 100 molecules to produce 200 molecules. If I take 99 molecules, 198 ions are produced. So due to production of more number of ions, due to complete ionization, right, there are this more ions present in the solution, acting, they carry more charge and LED glows so brighter, right? Where in the case of H2SO4, same, if you take 100 molecules, all the 100 molecules ionize to produce hydrogen ions and sulfate ions. You just guess here, if I take one H2SO4 molecule that split into produce 2 H plus ions and 1 sulfate ion. Okay, so each molecule, one molecule produced total 3 ions, 2 H plus ions and 1 sulfate ion. If I take 100 molecules, they produce 300 ions, right? So all these ions make, complete ions responsible for conductivity and LED glows brighter. Now in the case of CH3COOH and what is it? H2CO3, they are generally weak acids. These weak acids, what do? They undergoes partial ionization, right? Due to partial ionization, if I take like let's say 30 to 35 out of 100 molecules only undergoes ionization, so number of ions produced less, and the less number of ions carry less charge, so that bulb LED glows dim. Okay, not less brighter as in that of HCl and H2SO4, right? Now from this we also say, right, strong acids ionize completely, whereas weak acids ionizes partially. So the acids that undergoes complete ionization and produce high concentration of hydrogen ions, then they are called strong acids, whereas weak acids undergoes partial ionization and produce low concentration of H plus ions. So these all are the conclusions from this simple activity, right? Conclusion number 1, all acids produce H plus ions in their aqua solutions. Conclusion number 2, strong acids undergoes complete ionization, produce high concentration of H plus ions, whereas weak acids undergoes partial ionization and produce low concentration of H plus ions. Now what is the third conclusion is, you please note down these conclusions. Third conclusion is what? All acids contain hydrogen, but all hydrogen containing compounds are not acids. These are the 3 conclusions we derive from this simple activity. I hope you understand this activity, and to conclude, what is common in all acids we concluded H plus ions are common in all acids.